Bismillahirrahmanirrahim. Assalamu alaikum everyone. Dear students, hope you are fine. Welcome to regular chemistry first paper online class English version arranged by KPB School and College. This is Irene Parveen. Today I am going to discuss electron affinity, periodicity of valency and metallic character under chapter 3. The title of chapter 3 is Periodic Properties of Elements and Chemical Bonds. At first, I am going to discuss electron affinity. It's, it is also a periodic property. The energy which is released when 1 mole electron is added to outermost shell of 1 mole of neutral gaseous atom to form 1 mole anion is called the electron affinity of that element. Here some words are important. The energy which is released when 1 mole of electron is added to outer shell of 1 mole neutral gaseous atom to form 1 mole anion is called the electron affinity of that element. For example, here X is an atom which is in gaseous state. When 1 mole electron added is added to these 1 mole X atoms, then 1 mole X anion is formed and a definite amount of energy is released, and this energy is called electron affinity. If we use a definite example such as chlorine, 1 mole chlorine atom which is in gaseous state, when added 1 mole electron, then it produces 1 mole chloride ion which is also in gaseous state, and energy, and the amount of energy is minus 349 kilojoule per mole. Here for chlorine, 1 mole chlorine atom which is in gaseous state, which turns into 1 mole chloride ion, that is anion, and uh, in this case the energy released is 349 kilojoule per mole. That means electron affinity of chlorine is 349 kilojoule per mole. Now I am going to discuss factors controlling electron affinity. It depends mainly on the following factors. Number 1, size of the atom, that is atomic radius. Increase of atomic size decreases electron affinity, and it's a group based relation. Number 2, nuclear charge of atom. Increase of nuclear charge increases electron affinity, and it's a period based relation. And number 3, increase of electron density in outer shell and orbital in which electron enters. I will discuss these 2 points later while discussing the change of electron affinity in a group. Now I would like to discuss how the change of electron affinity of the elements in a period. For example, the change of electron affinity of the elements of second and third period. If we look this table, this is second period and this is third period elements. If we look this table and uh, if we go from left to right, we can see the electron affinity increase. For third period, we can also see the electron affinity increase if we go from left to right. Now, I will clear up the region of it. As we go from left to right, in a period, the nuclear charge of the atoms increase, as well as the atomic radius gradually decrease. So the distance of outermost electron from the nucleus gradually decrease, and as a result the attraction between electron and nucleus increase. That's why electron affinity also increase, and the electron affinity is highest for halogen atoms and zero for, look here, highest for halogen atoms and zero for inert gases. In inert gases, the octet is fulfilled except helium, and they have no tendency to gain or lose electrons. That's why electron affinity of inert gases is 0. Now I am going to discuss how the electron affinity change in a group. If you look this picture carefully, you can see that electron affinity decreases as we go downwards in a group. Electron affinity decreases as we go downwards in a group. Now I will give an explanation of it. As the size of atom increases in a group, that means if we go downwards in a group in the periodic table, then the size of atom increases. The attraction of nucleus on outer electrons gradually decrease. That's why electron affinity also decrease. But if you carefully look for fluorine and chlorine atom, here the electron affinity of chlorine is greater than fluorine, because the electron affinity of chlorine is minus 349 and fluorine is 328, which is an exception. And now I will explain this fact, why the electron affinity of chlorine is greater than fluorine. Fluorine is an atom of second orbit. If we write the electronic configuration, that means outer shell electronic configuration of fluorine, we can see that the outermost electronic configuration of fluorine is 2s2 and 2p5. On the other hand, the outermost electronic configuration of chlorine is 3s2 and 3p5. F is an element of second orbit. It has 2s2 and 2p valence electron. 2s2 and 2p valence electron. And chlorine is the element of third orbit, and it has also 3s2 and it has 3s2 and 3p 5 valence electrons. The outermost orbit of fluorine atom is second orbit and that of chlorine is third orbit. In both cases, 7 valence electrons. Both cases there are 7 valence electrons are present. The size of the second orbit is small. Hence, the 7 electrons cloud density in this orbit is high. Since the size of second orbit is small, therefore the 7 electrons cloud density in this orbit is high, and the electrons of the second orbit repel the incoming electron strongly. So the electron affinity of fluorine decrease. On the other hand, comparatively, the third orbit of chlorine is larger and at electrons, that means 7 valence electrons can accommodate easily. Hence, electron cloud density in chlorine atom is normal. So, incoming electron is attracted by chlorine nucleus mole. Hence, electron affinity of chlorine atom is higher than that of fluorine atom. There is a very common question which is important for board exam. The question is electron affinity of fluorine is less than that of chlorine. Explain it. This question is common for board exam. So memorize this question properly. Now I am going to discuss periodicity of valency. Periodicity of valency. The valency of an atom is its capacity to combine with other atoms for the formation of new compound. Valency of an atom is expressed in two units such as hydrogen or chlorine scale valency and oxygen scale valency. Combining capacity of an atom with hydrogen or chlorine atom is called hydrogen or chlorine chlorine scale valency of the element, and combining capacity of an atom with oxygen atom is called oxygen scale valency of that element. Now I am going to discuss the valency of different elements of third period. The outermost total electrons of atoms of group 1 to group 4 elements represents the valency of each element. Look here, here. Outermost total electrons of an atom is called its valence electron. Again, from group 5 to group 7, the hydrogen scale of valency of different elements decrease gradually. From, if you look here, hydrogen scale valency decrease gradually. At first, they increase 1, 2, 4, then they decrease gradually. But oxygen scale valency of those elements increases. Look here, oxygen scale valency increases. If we look the electronic configuration of group 1, here sodium, we see that the outermost electronic configuration is 3s1. That means there are only one electron, so valency of sodium is 1. And for magnesium, the outermost electronic configuration is 3s2. That means the valency of magnesium is 2. And for aluminium, the outermost valence electron is 3, so its valence is 3. And for silicon, outermost electron is 4, so its valence is 4. And after that, valency gradually decrease according to hydrogen scale valence. Now, I would like to discuss metallic character. Metallic character means electrical and thermal conductivity, metallic luster, malleability and ductility, and reducing properties. Generally, metallic character of element decrease from left to right in a period and increase in a group. Look here, generally the metallic character of elements decrease from left to right in a period and it increase in a group from top to bottom. In a period, the elements at the extreme left are metals like, look here, in a period the extreme left elements are metal and at extreme right are non-metals and between these metals and non-metals there are exist metalloids which contains some of the properties of metals and some of the properties of non-metals. The elements, the metallic character has a relationship with ionization energy and electronegativity of the elements. The elements having low ionization energy and low electronegativity are metals. If you look here, the ionization energy of metal is less than non-metal and the electronegativity of metal is also less than non-metals. And the elements with high ionization energy and high electronegativity are non-metals like the elements of group 6, 7, etc. Look here, the ionization energy and electronegativity both are high for non-metals. Both are high for non-metals. Metals have crystalline structure, so their melting and boiling point density are very high. In a period as we move from group 1 to 4, these physical properties increase progressively. Look here, for metal, density, melting point, boiling point, high, then the non-metal. Look here, then the non-metal, the melting point, boiling point, and density are very high of metal than the non-metal. The metals have good the metals are good conductor of heat and electronegativity, form positive ions, and they have also reducing properties. So, from the above calculation, above discussion, we can say that metal metals have a low ionization energy and low electronegativity. On the other hand, non-metal have high ionization energy and high electronegativity. And the melting point, boiling point, and density of metals are very high. On the other hand, non-metals have low melting point and boiling point. And if we uh, if we uh, go from left to right in a period, the metallic properties decreases, and if we go from up to bottom in a group, then metallic properties decreases. So my dear students, no more today. Practice these topics at home properly. See you again. Take care. Bye.